Hello folks, welcome to our lesson. So today we are going to talk little on a form 4 topic, floating and sinking, and we also talk of upthrust and relative density. So when we began the topic, we looked at the law of flotation, the Archimedes principles, and so on. So from the Archimedes principles, and this lesson we are focusing on more so on the Archimedes principle, which says that upthrust is always equal to the weight of the liquid displaced. Assume an object is immersed in water, could be either partially or fully immersed in water. This object, what happens is that it displaces a given amount of water or a given amount of liquid in which it is immersed in. So this liquid, the weight of this liquid displaced, according to Archimedes' principle, should be equal to the upthrust in this particular liquid. So Archimedes' principle can be used to determine the relative densities of both solids and liquids. And as we have just mentioned, that the upthrust, that is in Archimedes' principle, must be equal or is equivalent to the weight of the liquid displaced. So we are going to begin with the relative density of a solid. Well, let us go straight forward to the business. So relative density of a solid is given by taking the mass of the solid and dividing it by the mass of water displaced. When a solid is immersed in water, it displaces a given amount of water. So the weight of this water displaced is the one we are talking of. So relative density, take the mass of the solid, divide it by the mass of water displaced. But if you go further, you realize that mass is proportional to weight. Mass is proportional to weight. By this formula, that weight equals to mg. G is our constant. So here it means as weight increases, mass also does what? Increases. As weight reduces, mass also reduces. So weight is directly proportional to mass. So since we have mass, we can also use this formula and find the weight. We have the mass of the solid. We have the mass of the water displaced. By using this formula, we've said that gravity is constant and its value is 10. Its value is 10. So, relative density can be expressed, that is when we use now weight, can be expressed in this way, taking the weight of the solid. And how do we find the weight of the solid? Just taking the mass, multiply it by our constant, that is the value of G. Then divide it by the weight of water displaced. But initially we mentioned that the weight of water displaced, as stated, that is in Archimedes' principle, is equivalent to upthrust. So this formula can also be expressed this way. Relative density can also be expressed this way, taking the weight of the solid, then divide it by upthrust in water. Initially we were talking of weight of water displaced, but we've been told that weight is equivalent to what? Upthrust. So in the place where we have weight of water displaced, we can replace it with what? Upthrust. So weight of a solid divided by upthrust in water gives you the relative density of that particular solid. Let us go on and look at one example. We have a solid of mass 0.8 kilograms suspended by a string, and it is totally immersed. This solid is totally immersed in water. If the tension in the string is 4.8 Newton, tension in the string, this is the upthrust in the liquid. So we are told to calculate the relative density of the solid. First, you have to write the formula, equate the two. That relative density is given by the weight of a solid divided by weight, divided by upthrust in water. Do you have the weight of the solid? No, we don't have the weight of the solid. But since we have the mass of the solid, we can easily get the weight of the solid by use of this formula, that weight equals to mass times gravity. And we've just mentioned that gravity is a constant. This value is 10. We have our mass from the equation, which is 0.8. So take 0.8 multiplied by 10, and this gives us 8 newtons. 8 newtons. Maybe there are those people who might be asking, what is the SI unit? What are the units of gravity? It is 10 Newton per kgs. 10 Newton per kgs. In that, when you multiply, that is mass, which is given in kilograms. When you multiply mass, which is given in kilograms, by d given in newtons per kg, kilograms cancels the kilograms, then we remain with what? Newton. And as we know, there are weight, the SI unit of weight is what? Newton. So we remain with 8 Newton. So we've calculated for the weight of the solid, which is 8 Newton. And do we have upthrust? Upthrust from our question? We don't have upthrust. What we have from our question is the apparent weight. Apparent weight, the tension in the string. Tension in the string. That is the weight of the solid when it is immersed in the liquid, or when it is immersed in the water. So when this solid is immersed in water, the reading on the spring balance is 4.8 Newton. So we are taking this as the apparent weight of our solid. So how do we find upthrust? When we have the real weight of the solid in air and we have the apparent weight. So whenever you are given apparent weight and real weight, this is how you find upthrust. Upthrust is calculated this way. Take the weight of the solid in air, which is the real weight. We have its value as 8 Newton. Then subtract the apparent weight. Apparent weight, that is weight of the solid when immersed in water. So if you subtract the two, we'll find our upthrust as 3.2 Newton. So we have our upthrust and we have our weight of solid in air. And from our formula, we've been told that relative density of a solid is given by taking the weight of the solid, then dividing it by what? The upthrust in water. So we have our weight, that is 8 Newton, divided by our upthrust, which is 3.2 Newton, and since relative density is a ratio, Newton cancels the Newton. So our final answer will be unitless. Why? Relative density is a ratio. Ratios do not have units. Thank you. Thank you for watching this. Please subscribe.